This is Regenerative Skills, the podcast helping you to learn the skills and solutions to create an abundant and connected future. I'm your host, Oliver Gaucher. Are you left wanting more at the end of each episode of this show? Are these short sessions getting you fired up to try new skills for yourself and share the journey with others who are working through the same challenges? Well, the good news is that this podcast is only the beginning. The real action and learning is happening on the Regenerative Skills Discord channel, where you can connect with the whole community to dive deeper into the topics on the show, explore solutions, and share your journey and blooper reel with an active group that can't wait to hear from you. You can get your questions answered and share knowledge and wisdom of your own on a safe platform that, unlike the social media giants, won't steal your personal data to advertise to you in creepy ways. Ditch Facebook and join us where the real skill builders are. Just find the link to the Discord chat on the homepage at regenerativeskills.com. Hey there everybody and welcome back. So I'm going to start to build on last week's episode about designing and building wetlands by digging into the archives for some of my favorite episodes in the world of watershed regeneration and the adjacent topics around that. Now, I've covered this broad topic many times in the past, but I also know that there's a lot of new listeners to this show who probably have no idea about all the different options and solutions that I've highlighted here over the years. So, today we're going to take a closer look at freshwater systems, and specifically how to decontaminate them through biological methods. Now, some of you may remember an interview that I did with Tom Duncan in Australia about his floating wetlands and how they can be used to clean up excessive nutrients and pollutants back in season 2. But today I'll be expanding on that technique since it's gained a lot of traction and floating islands are popping up all over the world to help deal with contaminated rivers, lakes, and ponds. And I'll be sure to put a link to that interview in the show notes for this website in case you missed it. For this episode, however, I reached out to Galen Fulford, the managing director of Biomatrix Water, a biological technology company working on solutions for waterway and wastewater treatment based in Moray, Scotland. In this interview, Galen explains the science behind waterway contamination evaluation and the calculations that they do in order to determine restoration approaches and techniques that are appropriate for each site. He also breaks down how their floating wetland systems work and how they compare and differ from traditional wetland systems in the way that they decontaminate water and provide habitat and sanctuaries for wildlife. We also explore the challenges that installing floating wetlands in urban environments can entail, as well as some of the novel solutions in engineering that Biomatrix Water has developed in order to help their installations withstand events like floods and heavy contamination loads. So this is a really good episode for people who want to understand the biology and engineering behind some of the most promising natural waterway remediation techniques that are being pioneered today. So make sure you listen all the way to the end as well when Galen explains how these floating wetland systems are being applied to ecological sewage treatment and municipal water purification. So from here, I'll hand the discussion over to Galen. Hey Galen, thanks so much for taking time to be on the show today. How are things going up in Scotland and how are things going with your work?
Hi, Albert. Yeah, things are going very well with our work up here in Scotland. It's typically gray morning, but beautiful nonetheless. I was out for a bike ride along the beach and just connecting with the element of water before I delve into working with it.
Fantastic. Yeah, it's a part of the UK I haven't been to. Half of my family is from that region, but they're from further south in Britain, and that's an area I'd really love to come and visit sometime. But so to get us started, Galen, could you tell me about how you got started working in waterway regeneration? What sort of led you down that path?
Well, Oliver, basically I started out working in the US with natural wastewater treatment systems, constructed wetlands and multi-stage reed beds and so forth. And we were really looking at water treatment and water recycling. And from there, we were doing some projects in China and India. And it just, I remember one day being up in the Jin Mao building in Shanghai and looking out across this Shanghai and just the sea of skyscrapers. And it had the real impact on me to say, that we need to develop solutions and techniques and technologies and ways of working that are modular and replicable and scalable if we're to have a chance of making any kind of change in the world. And so that then led me down the path of looking for natural water treatment and water recycling systems, which are modular, scalable, and replicable. And that led me into the world of floating ecosystems. And we had been working with some at that stage, and they needed much more development. So I got to work developing different types of floating ecosystems. And over the years, we've discovered that there's a huge potential really in the area of waterway regeneration for the same, essentially the same module, which we also still do use for water treatment and water recycling as well, as a matter of fact.
It sounds like you've really moved from technologically based systems from what you were working in before. I assume that's what it was, and kind of mechanical water treatment systems more into biological ones. What sort of got you to look into those options and veer away from what we might call more traditional modern ways of purifying water?
I suppose that in actual fact, we've always been focused on the biological, um, and but we've been working more and more looking at different ways to harness that power in situ, directly within the waterways we're trying to improve. So rather than, I think, traditionally you have systems which are end of pipe or intercepting flows and so forth, and then discharging clean and treated water. And what we've discovered over the years is that there's many situations where that end of pipe situation is just not feasible. A, because there isn't a pipe, it's just an open sewer, or B, the pipe might be too hard to locate, or the pollution in the waterway might be non-point source, just diffused. And that has led us down to more in situ situation techniques. And we're still quite technical, and we're just commissioning new machines. We design our own hydraulic machines and everything that make our components. But all of those components are purely about giving nature the toehold that it needs to thrive and flourish and do what it does best, powered by photosynthesis and biology and ecology rather than, flocculants and chemicals and so forth.
Well, so before I start asking you about the components in your systems and sort of how you evaluate which ones will be appropriate, can you tell me about the challenges and the degradation that our rivers and freshwater resources are facing all around the world?
Oh, geez. I mean, it's just,
It's a big topic, huh?
It's so vast. And oh God, where to begin? I mean, if we look at places like Europe, everywhere is farmland. There's so little wildland left that everywhere is farmland. What that means is that you have massive amounts of nutrients and sediment running off into the waterways. And then those waterways are then channelized, and then they all go out into basically estuaries, eventually along the coast. And pretty much almost without exception, each of these estuaries has a city on it, particularly on the major river systems. So how basically that critical ecotone between freshwater, brackish, and then saline ecosystems, which are so critical to, for example, the salmon life cycle, are then decapitated with these hard-edged concrete and steel sheet pile walls. So that's one impact. Then if you go into places like India, you have just huge amounts of wastewater, untreated, flowing into the waterways. So that is a huge, huge issue. In most cities, you've got less than half the population actually connected to wastewater treatment plants. And so you just have huge amounts of raw sewage flowing into the waterways. And they then become anoxic, and basically the fish die, and it just kills the whole thing. They smell horrible, So loads of waterways like that. And then obviously you've got all the other rivers that are, up in the mountains. Maybe they've got some wilderness left around them, but by goodness, they're all full of dams. So a huge amount of impact on the world's waterways.
Yeah, there seems to be And I can't imagine when it actually started to be viewed this way, but our waterways are looked at often as free waste disposal alleys or methods. And even though obviously they're essential for so many functions in an ecosystem, where is this kind of breakdown in understanding of their value? And I'm kind of looking for words here as to where this may have originated and how you're working with clients to start at the source as to how these resources are viewed and the relationships with the communities that they pass through before you can go in and actually start to remediate the health of the waterways themselves.
Um, I mean, it's a process of erosion, in psychological erosion, I guess, in many ways. And I think that the other thing to keep in mind, which we sometimes overlook, we say, well, why are people putting so much pollution in the river? Can't they go somewhere else? But there's a real difficult physical reality that, if when we think about wastewater, gray water, storm water, it's going to go somewhere. We're not going to put it into a big tank and evaporate it into steam. So that water basically has to go somewhere. We can ground recharge as much as possible, which is really important, but essentially, excuse me, all that contaminated water, flows downhill and eventually makes its way into a water body. So if there isn't very rigorous treatment along the way, that leads to, ongoing pollution, degradation of the waterway or water body. And then that then reaches a tipping point where it's no longer, a pristine resource that you want to drink and swim and, frolic in, but becomes something which is past that tipping point of vitality and abundance, and then it becomes essentially a waste transport system. But even our, everywhere around the world, the rivers are where the wastewater and stormwater ends up. The question is there sufficient treatment along the way to make sure that that doesn't have such a detrimental environmental impact that it pushes it over a threshold? And often that threshold is called the total daily mass load of pollution that waterway can handle. So basically there'll be a environmental agency or EPA study of a waterway and watershed, and they'll say, okay, well, based on the volume, flow, ecology of this river, we think it can handle X number of kilograms of phosphorus and nitrogen per day without tipping it into eutrophication, etc.
I can only imagine how far beyond that limit so many different waterways are now.
Oh, yeah.
I really like that you sort of broke down some of the macro issues at different regions of the world. Certainly on an individual basis, the context of each one is probably a lot more nuanced and complex. How do you assess a new project and sort of calculate or determine the measures and approaches that will be effective for that project's remediation?
Whew, gosh.
I'd imagine it's a long process. Do you have sort of a playbook that you follow? Or do you really take it on a context basis and rewrite the steps as you go into something new?
Well, basically, there's a couple of different ways that we approach it. In the first instance, it's important to keep in mind that the process of a waterway becoming degraded, reaching that point where it exceeds its, stated or, real world total daily mass load, tipping over that balance, the ecology beginning to crash, it becoming, anoxic, fish beginning to, go elsewhere, etc. It's not like somebody made one decision that happens. It usually happens little by little by little by little, with one inflow, another inflow, and then another inflow, reaching that point when the waterway or the ecosystem can no longer cope. So the reason I think that that's important to understand that step-by-step process is that the process of restoration is also step-by-step. It's not so much a case of saying, okay, there's that river, well, it needs, 2 paracetamol, 3 ibuprofen, 45 floating ecosystems, 2 new wastewater treatment plants. Usually that's not feasible for financial and political reasons. Although ideally that is really what you would want to do. So we do a system where we basically survey the water body and we measure the flow, and then with the flow we measure the concentration of different nutrients. That then gives us essentially what equates to a mass loading. So multiplying the milligrams per liter by the flow down the river, we can determine essentially what the kilograms of nitrogen, phosphorus, BOD, TSS, COD, etc. are in that river. And that gives us a sense of what the mass load of pollution in that water body is. And then we can look at a prescription or a series of solutions to solve that problem, to reduce that mass loading to a level that we would be aiming for it to come back to life. 2 to 3, ideally up to 5 milligrams per liter of oxygen, for example, that kind of thing. And so we do that. It's a process of combining hydrometry with water chemistry on site. And the difficulty with it is that obviously the waterway is changing, hour to hour, diurnally, seasonally, etc. So your snapshot of mass loading is only one point in time when you carry out that hydrometry and so forth. So you can mitigate that by composite sampling and so forth and doing it over the year, but you can see that it quickly becomes quite complex.
Yeah, definitely. I'm glad you brought that up, because anytime you're gathering data from a dynamic living system like that, you're only getting a snapshot like you mentioned. And is it a matter of compiling sort of an average among different seasons, or is it really worthwhile to look at, okay, these solutions are going to be appropriate perhaps at this time of the year, but there needs to be a different strategy as it goes into different seasons? Or, if there's a flooding event, the installations are going to have to be able to take the difference in circumstances or be temporarily removed. I mean, is it really looked at a seasonal and time frame basis like that, or do you kind of go through mainframe solutions and look for things that are going to work generally, even if not terribly specifically, for an entire year or an entire period of time that you're looking to make something effective?
We would be looking for something that will be working, most of the time. We definitely don't want to be taking things in and out. But in practice, what ends up happening is that it's, each project is a step on the way towards restoring health, biodiversity, and vitality to that water body. So rarely does anyone or even any government have the opportunity to say, right, let's sort out that river. We're going to, build these 5 new wastewater treatment plants, this, 20 million in stormwater, mitigation, all these, riparian ecosystems. That just rarely happens because of the financial and physical constraints. So what does happen is many projects progressively being implemented to progress the waterway back on a course to health.
That makes sense. So can you tell me a little bit about some of these solutions and steps towards reviving the health of a waterway that you have been involved in implementing?
So typically, you would be looking at doing some more wastewater treatment. So looking at where the main offenders in terms of influent pollution loading, and those can be determined through their mass loading discharge, and trying to implement secondary or tertiary treatment stages on the back end of those, often ecosystem integrated, constructed wetlands, going into helix flow reactor type of activated wetland systems to provide additional treatment. And that work is happening all over the place at the moment. Regulations are getting stricter in the US, in Europe, in Asia, all over the place. People are trying to improve those discharges and building new wastewater treatment plants with stricter regulations. So from then the next area becomes the stormwater loading. huge amounts of stormwater are flushed into our waterways and there's fantastic legislation which is getting better and better all the time around stormwater, SUD systems, sustainable urban drainage systems, absorbing more of that water into the ground and also improving the quality of it, providing 1, 2, 3, 4 steps of treatment before it actually is discharged into a water course. So that's another area where we work in stormwater systems, providing stormwater ponds that have aeration, circulation, floating ecosystems in them, active edge filters, these kinds of things to help to ensure that the stormwater flowing into the water course is also mitigated and balanced. Then thirdly, we work directly in the water course or water body itself with floating ecosystems, solar active island reactors, these types of things to provide direct in situ water quality, habitat, and biodiversity enhancement.
Well, so let's take a closer look then at the floating islands, because I know that this is one of the solutions that Biomatrix Water has been best known for, perhaps most visible for. Can you tell me a bit about how they work and where they're appropriate?
Yep, sure. Basically, the floating ecosystems are really most applicable and most appropriate in locations where you need a concentrated ecosystem, wetland ecosystem effect. And you can either integrate them with stormwater or wastewater systems to provide a natural element to those that is essentially utilizing photosynthesis, the relationship between the bacteria on the plant roots and the biofilms that grow there to help to naturally enhance that treatment process. Or you can use them directly in the water course. And we don't typically install floating ecosystems out in the countryside in areas where you have lots of existing ecology and riparian edges already doing their thing, because there's not so much of a need. However, in areas where you don't have that natural riparian ecology, those natural treatment processes functioning as efficiently, or literally because often there's physical constraints, that's where floating ecosystems really come into their own. So most of our projects actually end up being in urban and peri-urban areas where you have hard vertical walls and essentially a decapitated aquatic ecosystem where that whole rich, incredibly biodiverse and beautiful and functional edge of the waterway is just cut off by the hard infrastructure. So, and often that can in some places be overcome through removing those hard edges and then sloping back the edge. Typically that slope would be at a 3-to-1, 4-to-1, a very shallow gradient, as you would find on the edge of most waterways. However, that achieving that shallow gradient within a suburb would mean often hundreds of houses having to be removed, and that streets realigned and everything, and that very quickly becomes unfeasible. So we can restore that riparian edge simply by putting it into the water in a floating context. So we have that all of that rich diversity that we would normally have at the edge of a waterway suddenly is able to, boom, within a few months, burst into life right along the edge of the steel or concrete edge without impacting any of the infrastructure or incurring all those costs that would be associated with it, without taking up any more land. And additionally, within that ecosystem, we can really optimize it and design it in a way that it can be very rich indeed. So we have, for example, elevated tree planters or submerged gravel beds. In a place like the Chicago River, for example, there's so much silt and sediment in that waterway that there's no kind of spawning or breeding gravel at the bottom for the invertebrates and fish that like that kind of substrate. But we can actually create a suspended hanging gravel bed to provide that habitat within that ecosystem. And, so then there'll be a flood, and that whole gravel bed will rise up with the flood, 1, 2, 3 meters, and then settle back down. So it's quite a dynamic and interesting type of ecosystem.
Yes, fantastic. And I've seen a couple of companies that have their own versions of these floating wetlands. It's basically a way of putting in the ecosystem function of a wetland without having to eat up the amount of land that it would normally take. But because these are suspended in the water, because they're floating and the root systems are down in the water, they function a little differently than a conventional wetland or swamp area where the roots aren't necessarily exposed. Can you talk a little bit about how they function differently biologically and if there are any advantages or disadvantages to each?
Yeah, it's interesting in its difference, because basically all of the wetland plants that we would typically be planting, traditionally they are found growing in the mud. So they're absorbing their nutrients from the sediment. But when we put them into a floating ecosystem, there's no sediment, and it's basically a hydroponic system. So the roots grow right through it, and we design the layers of material within the ecosystem very carefully to allow that full root penetration down into the water. And because there is no other where else for them to get their nutrients, they're not growing in the sediment, all of their phosphorus and nitrogen and so forth that they require for their growth comes directly out of the water itself. So that's a real benefit to water quality, which you wouldn't achieve if that same plant was actually just growing in the sediment at the riverbank.
Yeah, so it seems like you're getting a whole lot more surface area of filtration doing it this way, and that there are also other benefits for having these root systems in the water that create ideal spawning, conditions or protection for wildlife. And it's almost like a concentrated way of including the benefits of a much larger wetland and being able to place it just about anywhere, like you said, in these sort of hard and cut off barriers in urban and peri-urban environments.
Yeah, absolutely. It's also a very challenging environment for engineering. You've got flooding and debris flowing down the river, and all sorts of issues that really have to be taken very carefully into account. But when you get the design and the technology and the materials right, it can be incredibly versatile and functional. And we typically have kind of mixes of ecosystems, not such wide expanses, but more kind of pockets and open pools, and that's what really gives the rich diversity. And in many ways, it's like a riverbank or a stream bank that's kind of undercut with moss, and one of those great areas where the trout are kind of hanging out on a mountain stream, where you lean over the bank and do the famous trout tickling. It's kind of like that ecosystem. And when we put a camera underneath, we just see loads of fish and eels hanging out under there. When we put in an open pool, birds like crested grebes swim underwater and pop up in the open pool, make their nest in that sheltered environment that they can only access by swimming into. So it provides quite a unique habitat, as well as functionality with the roots absorbing nutrients directly from the water.
Tell me a little bit about how you make these floating islands, what the materials are, and can you give me maybe a cost estimate for a typical floating island of the dimensions that you're familiar with? Yeah. Sort of a little case study, something for reference.
Sure. So when basically back in the early days when we were said, okay, great, let's utilize some more of this, let's see what's out there, and maybe we can buy some of these components from so-and-so. And what we found was that there are some different things available, but there's nothing that really met either the structural or sustainability requirements that we have in mind. So we didn't want to use any foam. We didn't want to use any polystyrene or polyurethane foams because we felt like it was important that the materials that were utilized in this were as absolutely sustainable as possible. And we also felt like we didn't want there to be any potential for plastic fibers, microplastic fibers, or things that are kind of non-woven to erode away. And we found that these were very common features within the available technology on the market. So that sent us back to the drawing board to say, okay, well, we know we're not going to do that. What are we going to do that's different? And we also found that we were getting inquiries for projects and people really wanting to invest in restoring their waterways, but the locations were often very challenging in terms of physical considerations, floodwaters, changing water levels, this kind of thing. And the structural capacity of, the force of a river in flood, for example, it's, you can't laugh it off. You really have to think about it carefully. So we also found that nothing was meeting the structural requirements. So that also drove us back to the drawing board. So what we developed is really it's a very engineered and structural system at its base. And basically it involves a recycled HDPE flotation pods. And those we can configure in all different ways. And we had to invent and develop a special machinery to make these pods from recycled material that just didn't exist anywhere previously. And we're very excited. We're just commissioning the next development of this special machine. So we take these recycled HDPE flotation pods, and HDPE is basically the same material that's used to make drinking water pipes. So all around the world, when they're laying these pipes and they do this fusion to lay them in, that's really what's used. All of our drinking water comes through these days. So it is a plastic material, but it's a very inert plastic material. Different plastics have things that make them soft, etc. So on the one hand, you have materials like PVC, which has, releases all sorts of stuff into its surrounds and is not at all a material that we would want to be using in this situation. So we never use that. On the other hand, you have things like HDPE, which is much more inert and is, food grade material. And then we take that HDPE and then we take it in a recycled stream. So it's often actually from, upgrading water pipes that are pulled out of the ground, ground up, and then we remanufacture them into our buoyancy pods. Then we connect these together with marine grade stainless steel. And we have developed a whole bunch of special components that allow us to connect these in really structural and useful ways that we can have all sorts of adapters and connectors and so forth, but that can respond to the needs of different shapes and designs, as well as the dynamicity of different water environments. And then we have a whole range of different planting substrates that we utilize. So we go from a 2D threat spec to 2D, 3D, 4D, and we're just working now with 5D specification projects, which utilize wood chip and clay material as the planting substrate. And we've also just been launching new systems which are actually using Scottish oak as a part of the edging to help hold in the different planting materials. So essentially our component and material philosophy is that everything that we should use, everything we want to use to design this ecosystem should be, in the first instance, organic and natural, but where we require the real engineering and longevity of a fully infrastructure quality system, then it should be recycled and recyclable. So that's where we go into the HDPE and the stainless steel. And so that's kind of the material composition, if that makes sense.
Yeah, and it seems like, if you're creating sort of the gold standard of these floating systems that are meant to withstand not just the installation of the project, but also as it becomes more mature and it grows and it develops in its location, that it'll still hold up to that as well. That you really have to be very selective about the materials that you choose. Not many are going to fit that description. Is there a way of doing this as kind of a more temporary floating system with predominantly natural materials, knowing that it's probably going to decompose and need to be reinstalled within a certain period of time? Or is this really the best way that you've found as a balance between the natural materials and the higher engineered stuff for the most effective installation?
So if you have water that's, maybe 2.5 to 3 feet deep, you can utilize an interesting system that's completely natural and you can do yourself, where you basically build up the elevation. So basically planting into that water depth is very difficult. Many water plants will grow in, 2 to 3 feet of water, but it's very hard to establish them in that depth. You can imagine you're taking out a little plug plant and, reaching way down into the mud to try and plant it. It can be quite difficult. However, what you can do in these situations is basically use a bundle of brush wood and plant into that. And as the plant grows and matures, the brushwood will biodegrade. And so basically you're slowly bringing the plant down to the sediment level as it's growing in height. So that can be a really nice system, which is completely natural and you can do yourself. And just want to make sure that your brushwood is tied with natural, jute or coir cordage. And often within that, you would bundle some stones to hold it in position or use chestnut stakes to stake it into the side. So that can be a really good solution. When you get into deeper waterways with more energy and flow to them, it's very difficult to do with just natural materials. So you might think, oh, okay, we can make this with bamboo and so forth. And you can, but it becomes difficult. What happens when that starts to degrade and suddenly you've got a big chunk of, bamboo and plants floating off down the river? Is that going to get stuck under some bridge or on some boat or something? So it as attractive as it is, and I have made islands in that way, and they're great fun to do, but it's not something that you can really scale and replicate within an urban environment at any great extent.
Well, I'm really glad to hear that you've tried this out in a number of different ways. Do you have resources or links that you can share to help listeners figure out how to make some of these things that are lower cost and mostly natural materials for experimentation on their own sites?
Oh, geez, I haven't put together a how-to on that type of system. It's very much a kind of making it up on site, but really you're just trying to use whatever natural materials you have available. So it's kind of, I think what gets difficult is when you have people doing do-it-yourself kind of homemade systems from not natural materials. So then you've got people, putting chunks of styrofoam and all kinds of stuff and lashing it up with fishing line and rope and pieces of net and so forth. And the difficulty there is that you rarely achieve a durable quality or a really good result. So then you're left with partial success and something that ultimately ends up becoming non-biodegradable aquatic rubbish.
Yeah,
And
you want to be careful not to contribute to the contamination while trying to eliminate the contamination.
Yeah, and so we encourage people to think really carefully about that. But I'm a do-it-yourselfer myself, of course. I want to figure out how to make things. So you just have to be prepared if you're going to mess around to take stuff out of the water when it doesn't, isn't fully successful, if you need to. And also, I would just strongly discourage people from using any kind of polyurethane or polystyrene foam because it's not particularly non-toxic. Those do leach endocrine interrupters and so forth, And also they break up and they're very difficult to recycle. So I would discourage from those. But natural materials, basically you're just trying to build up an elevation to get things up to the right level so that you can put plants into them.
And so once we get to the point where we can start planting these mediums, how do you go about selecting plants that will be appropriate and will be effective in water remediation?
I mean, you just go out on the waterway and look what's growing there and check to see that it's native to the region. And in general, the more robust the plant is, the more robust its root system is also going to be, and it will be able to thrive. Plants love to grow in situations where they have unlimited nutrients and unlimited water. And if you can also put them in a floating ecosystem where they don't get smashed by flooding every year, because most riparian banks will experience at least some degree of flooding, then they really, really thrive. So, all the different types of reeds and rushes, sedges, etc., they tend to do very well.
Yeah, and it's good to have reference just in the local area because those are the things that are sort of acclimatized to that. And if you start bringing in things perhaps from other climates or different areas, they could either become invasive or, I guess, not survive the conditions there as well.
Yeah, it's very important to utilize local plant material where, and definitely not be introducing anything that's, invasive or anything. And on the really upside, you're harvesting seeds locally from the bioregion or from the same watershed and growing them on and planting them in. So at this time of year in the autumn, we've been out and collecting seeds and that will be planted, after Christmas, basically at the start of the new year, and will provide our local British plant material for some of our projects. Particularly, we're harvesting at the moment plants for saltwater conditions. So we're out in the dunes and gathering some, angelica and sea mallow and things like this that actually you can't even buy if you wanted to, and propagating those for our really special projects.
Hey, that's exciting. So up until now, we've been talking about the application of these floating islands and different biological water remediation for streams, rivers, lakes, but you've also pioneered using this as sewage treatment sort of in a contained system. Can you talk about how these floating islands can be used in tanks of water in a sequence and in a series to purify sewage without nearly as much, say, fossil fuel inputs and using mostly biological systems?
Sure. I mean, basically, on the one hand, you've got activated sludge, conventional types of, treatment systems. On the other hand, you have very, very natural systems that really are like reed beds, constructed wetlands that use almost no energy and are really wonderful. The difficulty with those sometimes is that they're quite area intensive. So you very quickly end up with to deal with the wastewater from any reasonable size of population, you can quickly end up with a huge area of constructed wetland. And if you have the area, that's fantastic. Just utilize it. But if you don't have the area due to land constraints, et cetera, which often is the case, then there is a middle ground which utilizes some of the aeration and circulation engineering features of an active water treatment system and a lot of the benefits of the natural system. So we call this a helix flow reactor, and it's a type of wastewater treatment reactor that basically spirals the water around in a helical pattern, in a serpentine pattern through it. And we've been really focused on reducing the land area as well as the cost of that system. So we utilize a lined lagoon as if it was a constructed wetland, but with the water far, far deeper than you could otherwise establish to grow plants in. So typically your constructed wetland would have gravel, et cetera, in it, but we just make very deep water. That makes the footprint much, much smaller and then we float the ecosystems on the top and suspend baffles within it to create this serpentine helical flow path. And that's a very nice integration between the two systems. And so by harnessing more natural treatment capacity, we're able to extend the hydraulic retention time and reduce the requirement for aeration, for example. Although we do put aeration in as well, it's not as intense as it would need to be. And also we're significantly able to reduce the sludge management costs. So in conventional wastewater treatment, you're heavily aerating, generating a lot of sludge as quickly as you can, because that sludge is what precipitates out of the wastewater and is left with the clarified supernatant, which becomes your treated effluent. In a helix flow reactor system, we extend that process slightly so that we allow nature to do more of the work, and also we accumulate the sludge in the bottom for up to a year or more, and that allows natural processes to help to break down that sludge, reducing its volume as well.
That's really remarkable. Can you give me an idea of how much space perhaps is needed for a population in order to purify their sewage?
So in a constructed wetland type of system, you'd be talking about somewhere between 2 to 5 square meters per PE, person equivalent of area, typically, depending on temperature and so forth. Whereas in a helix flow type of system, you have multiple people per square meter of system.
Yeah, that's a very drastic difference.
Yeah.
And have these systems started to be implemented in any notable cities, or are there case examples of this working in places that have already kind of had a success story to back them up, or is it really just starting to become well known enough to take on the first projects?
Yeah, we have a number of these out there. So mostly in industrial sites, distilleries, breweries, and so forth. And yeah, so they're working well in that regard. But those are also quite difficult waters. So they have got their own challenges, residual alcohol and stuff in the water. The wastewater sector as a industry sector or technology sector is extremely mature, very regulated. So it's quite difficult to bring different technologies and different solutions into, and there's an extremely strong drive for all wastewater to be connected to sewage mains and to go to centralized sewage treatment works. And the historic drive for that is really to essentially increase control and management and improve effluent quality, and so that there's not lots of little systems. But the downside of that is it makes it much more difficult to regionally or on a district basis reutilize treated effluent within the landscape for groundwater recharge, non-edible crop irrigation, etc. So we found it, to be honest, quite difficult to crack into the wastewater market, and the waterway restoration side of what we've been doing is just so busy. We haven't had as much time as we would like to develop that further.
That's interesting. It makes sense, but it also brings up the issues of less resilient water treatment systems for municipalities and bigger risks of single points of failure rather than a decentralized system where perhaps every residential neighborhood could dedicate a certain amount of land to treat their own water and return it back to the system in a way that benefits the residents. Tell me, I guess, how people could get into learning more about this and perhaps even getting to the point where they could start experimenting on a small scale and implementing some of these projects where they happen to live.
So most of our projects begin in a really beautiful way where somebody hears about the work that we're doing sees, before and after pictures, for example, of hard edge and then what it looks like afterwards, full of life and diversity. And they realize that there's a hard edge waterway where they live that could benefit from this type of system. So often it's an individual who gets inspired and sees, hey, why can't we do this here? And we'll get an email or a call, or somebody will see something on Instagram or something and just be like, hey, how come we can't do this here? And in many cases, it's not somebody with, a budget or anything like that, and certainly not a budget for this type of work, but it plants the seed of possibility. And from there, we explore options. So we say, okay, well, if we wanted to do this here, let's not worry about the funding side of things. Let's just collaborate on the vision for what this waterway could possibly look like. And we used to have a great time just working with people just for fun to see what it could look like. So we'll sketch things out in 3D with plants. We send people KMZ files that they can put directly into Google Earth and zoom around it and rotate and look at what their waterway could look like, with a floating riverbank along the side of the wall at it. They can share that with their friends. They can share that then with their local regulators and water companies. And pretty soon it begins to build momentum and interest. And then, a year, 2 years down the line, there is some funding potential available. And that's really how these projects take off and get rolling.
That's fantastic. That mirrors a lot the design process that I've worked with and I've known others to do with different restoration projects. Is you start with sort of the goals and the visioning, and from there sort of reverse engineer from what the ideal outcome could be to get to projects that are feasible to get started and to build momentum towards that end goal. Can you tell our listeners where they could learn more about the potential of these systems and waterway restoration, and how they can find out more about the company Biomatrix Water?
Yeah, I mean, great place obviously is just to come straight to the website and take a look, biomatrixwater.com. And my favorite part of the website is actually the news section. And if you just click on the top headers and go down to news, you'll see all these different case studies, and usually with video and quotes and pictures and everything of what we've been up to lately. And that's a great way just to see what the potential is, to get some inspiration. That's my favorite part of the website. And from there, then you can look into different applications and components and so forth. But typically, people give us a call or send us an email to solutions@biomatrixwater.com, and then we can explore the different options from there, and have a phone call and do a Google Earth fly through tour and very quickly identify where there's potential, where there's constraints, where there isn't potential, and that can be a lot of fun just to have a call and look at what the potential is in your local city.
Excellent. Well, for the people listening, I definitely recommend that you reach out and start envisioning what could happen for your waterway as well. And I want to give a shout out to Lisa Shaw, your colleague and art director of Biomatrix Water, who is a co-instructor on the ecosystem restoration design course that I teach through Gaia Education and ecosystem restoration camps, who really turned me on to your work, but also the fantastic way that she has communicated the potential of this and illustrated some of the case studies through her own artwork. And I know that adds a really dynamic element to the projects by bringing in the aesthetics and the community influences as well. Before you go, can you tell me a little bit about how that has added an extra element of connection to some of the projects that Biomatrix Water has done?
Well, I think in our core values as people, Lisa and I founders with Michael Shaw, and as a team here, our core value is really about doing things that make the world more beautiful and healthier. And so we really enjoy the element which is creative and artistic. And Lisa's a wonderful painter. And so to bring in that kind of fine art element and then blend that with, photography and the videography and so forth, it just all goes together with our vision of creating it more beautiful. And we also see that the beauty also comes in the context of the way that we relate to each other as people and the way that people relate to the other species on this planet. So we also really love and enjoy the interaction with the volunteers and community members that help bring these projects to the next stage with us. So we're never really involved in kind of sales type conversations. It's really about how do we work together with the tools that we have, with the resources available to bring waterways to life.
Those are wonderful words to end on. Galen, thank you so much for taking the time to explain the details of some of these systems, the challenges facing our waterways, and I really look forward to staying in contact and maybe doing a follow-up as you continue to develop the products and the systems that you guys are working on. So thank you. Now, before we wrap this up, just remember that these episodes are only the beginning of the learning resources, design and coaching services, in-person courses, and interactive community that are available through Regenerative Skills. The Discord server is our free community where you can connect with other like-minded listeners, exchange ideas, stories, tips, and resources, as well as interact with me directly and quite a few former guests from this show. Our Instagram account @regen_skills is the best place to see the projects that me and the team are working on, both for clients and collaborators, as well as on our own properties. I'll also be announcing the certification courses, workshops, and gatherings that we've got coming up later this year. If you're interested in getting dedicated support for your own project, you can now schedule a free planning session with one of our team members through the request form on our website. You can also find all the links, show notes, and past resources there at regenerativeskills.com. We truly believe that no matter your experience, your knowledge, abilities, resources, or background, you can be a powerful force for regeneration on this planet, and we're here to help you find your path. So as always, remember to keep taking those little steps every day towards a regenerative future, and I'll be right by your side along the way.